And then the next one that you see is this guy.
And it's attenuated because
It's attenuated because it's gone all the way down the cable, come back. And this distance here, in time, is 2 times L.
Right.
Because it's gone all the way down and come back again. So it's always 2L. Now the number they give us, for EPR, the number we were coming up with for the speed that it's travelling through the cable was something like 540 feet per microsecond. So every microsecond the pulse is travelling 540 feet. So if you know the distance between them, you can work it out in time. So once you've done a calibration on the system and you use the calibrator for that, so we're assuming that that's at a level that's way below anything that would cause a fault. Because at this stage you don't want to see the fault. You just want to get a feel for the time period that you're interested in. Because you could have an infinitely long period of time where you know that there's nothing happening. Now if it was a perfect world, you'd only ever see 3 pulses. You'd see a pulse from the front, a pulse from the tail, and a pulse from the fault itself. So a front to tail. So you only ever see 3, and they'd be so obvious. You'd say, "I'm good. I know where it is." That never happens. So it's physically useful to tell the system, or see yourself, how far they should be apart when there's no fault, because you know that distance is the distance that, I wouldn't say it's of no interest to you, but it gives you the length of the cable. So if you see a pulse that's further than the end of the cable, you know it doesn't belong to you.
Right.
It doesn't make any sense.
It's some kind of reflection.
Yes.
Or something.
And you'd actually see, if you were to actually look at this, and you see this when you're doing length calibration in the auto, you'd actually see it kind of looks like this. Is what you see. So you'd see the length, and then the length, and then the length.
Right.
And it's exactly the same distance apart. Because when that pulse travels up here, comes back down again, when it hits this end, it's a discontinuity. So it reflects up here again, and then again, and again, and again, and again. And it'll keep going until it's attenuated that small you can't see it.
Right.
So it just keeps multiplying it down the cable. So that's really the simplistic point of view. You're going to have 2 pulses here, and you're looking for something that belongs to the fault. The thing that kind of screws you up a little bit in the representation is, if you just looked at the representation directly, and this I think is what screws up most people, is you say, well, if that's the pulse from the front, and that's the pulse from the tail, if I see a pulse here, the distance from, we won't call them front, we'll call them power and non-power. The distance from the power end is right there. I'm good. It's whatever that is. And that's the distance to the non-power end. Well, that's not true. Sorry. What actually, if you look at it as just a simple graphical way of doing it, is, let's say my fault is, I do it simply just say, my fault is 1/4 of the length. And this is L. The fault is 1/4 L in, right? So that's where the fault is, right? So, I get pulses from the fault, because that's what you do when you do site locating. You've turned off your calibrator, and you're looking at pulses that exist at the fault area. So, there'll be a pulse will come this way, and pulses will also go that way. And it'll happen continuously, so there'll be tons of them. But when you try to capture one area of time, you just capture one operation, if you like. So the first pulse has travelled 1/4 L. So when I see my screen again here,
You can erase that stuff down below.
can you? Didn't know it was important.
Well, I've got on video, so we can put them back if we need
Oh,
to at the
okay,
end.
gotcha. So we've travelled, the first pulse has appeared, Let's try to do this again. This first pulse has appeared after a quarter. It's travelled a quarter of the length. So this is because I don't display it until it gets here, because I can't see into the cable.
Right.
So I won't see it until
So
it's
the
travelled to
first
the
thing
end.
you see is
A pulse that's travelled from the fault to you.
right.
So it's already old by a quarter of the length.
Right.
It's already aged. It's the same thing as using a space telescope.
Right.
And you look out at a planet and you go, oh, there's a planet there. And then you actually find out that it's not there, because it took the light that time, time to get to you.
That's
that
what
you're
it
always
was
looking in the past.
10 minutes ago.
Right. So you're looking in. This is what happened quarter of an hour ago. So here you go. So meanwhile, your other pulse, that's still travelling, and that travels all the way to this end of the cable, and then it returns, and it comes back here. So the second pulse,
That's 1 3/4.
correct. The second one has travelled 1 3/4. So 2 has travelled 1 3/4. That's the distance, right? It's travelled that full distance plus 3/4, which is the opposite side of it. But the problem that you have is that you haven't seen this for a quarter of the length. Meanwhile, that travelled a quarter of the length. So by the time you saw this, that pulse had already been in transit for a quarter L. Right? So you don't see that either. That's
Okay.
basically subtracted from both.
Say it again
This pulse travelled a quarter of the length.
now. Right.
This pulse, during that period of time,
Also went.
also travelled to there.
So it's halfway the cable.
So it's already halfway up the cable. By the time you saw it here, it's already travelled. So when you see this pulse, you've ignored this time because you didn't know it was there. Which also means you've ignored that time because you didn't know it was there, because that occurred as well. Right? So I've got to subtract off here a quarter L. Right? So now I'm left with 1.5 L.
Right.
Well, we know that the fault was 3/4 L, wasn't it? This is the actual fault distance from the tail, was 3/4 L, wasn't it?
Mm-hmm.
What's half of 1.5?
3/4.
3/4, right? So what you've done is, this distance you see here, when you visualise it, when you see that pulse, the distance from here to that pulse that you see on the screen is twice the distance, which we knew that, but it's twice the distance from the fault to the tail, not twice the distance from the fault to the front, because that pulse isn't coming to you, it's hitting the back end and coming back.
Okay.
That's what fools you.
That's what I could. I couldn't make sense of that, like how those distances. I don't know. That makes perfect sense now. Thank you.
Because that's what you forget, is that this one's travelled, whatever this travelled, till you see it, this pulse has travelled the same distance. So you've mentally subtracted that one, because you never saw that time, because that time was nothing to you, because the pulse wasn't even there yet.
Right.
By the time you saw it, this one's already moved. So you're always seeing a pulse, the pulse that belongs to the fault, and the tail end pulse, and that can be pretty small actually. But that first pulse is the tail end. So when you look at and it represents it in auto PDSL and quick PDSL, the picture is actually the same. It takes the same snapshot. It doesn't do any mental reversing. It doesn't do anything of that kind. It shows you what exactly happened in time. So this would be the cable. That would be L. This is 3/4 L. And this is 1/4 L. So when you actually have a look at when it gives you to top and to bottom, if you look at those numbers, you'll see that the distance from cursor, which is here, to top will be that distance, not that one. So they don't reverse the picture, but they reverse the measurements. So it looks a bit confusing because you go, well, that's the longer distance, that's the shorter one. And if the top I have power on it, why isn't the top the shorter distance? I don't get it. Well, what's it trying to tell me here? Because it's realised that the pulse that's appearing here travelled from the fault backwards, not forwards. So it's inverted. So it always gives you the wrong impression when you first see it. And
But
it's
because we hook it up backwards.
That's true too. Absolutely, yeah.
It's that.
I don't know what that means.
I don't know.
Is that like a stuck again? Is that a test or what?
I don't know.
Giving us some kind of hint, I suppose. Seeing buzzy alarms.